To begin with, the ladder had 60 kilograms of weights attached to the bottom rung to represent someone footing the base. The technician was asked to attempt to make the ladder slide sideways. In tests 10 to 14, the technician found it almost impossible to make the ladder actually fall over sideways. In test 15 onwards, the 60 kilograms footing weight was removed, so this is now a completely unprotected naked ladder. Now when he leans out, the naked ladder behaves totally differently. The 60 kilograms footing weight had not been preventing sideways slip, it had actually been keeping the feet of the ladder on the floor and preventing flip. Flip is when the user leaning out causes the ladder to rotate and collapse. In test 17, the ladder is footed by a large technician who struggles to prevent flip. In test 18, with a naked wooden ladder on stainless steel, it flips immediately. In 2002, the HSE commissioned the ergonomics department of Loughborough University to carry out research into ladder stability, using volunteers from both industry and the general public. This 250-page document became known as the 2004 Loughborough Report, and it identifies 4 main modes of ladder failure. Bottom slip. This frequently happens on slippery or loose surfaces. Loss of top contact can be caused by the user aggressively drilling into the wall. Flip. This, as demonstrated previously, is caused by overreaching the ladder on one side whilst hanging onto the other ladder style. Sideways slip. Again, as demonstrated, it's not sideways slip that causes the accident, it's when overreaching one side causes the base of the other style to leave the floor and the ladder rotates around the other style, turning the movement into flip. Fitting a wider stabilizer bar to the ladder offers little improvement, as overreaching still encourages flip. Also, the feet of the stabilizer bar, just like the naked ladder feet, are still prone to bottom slip. As well as identifying the modes of failure, Loughborough also designed workshop tests to evaluate the performance of stabilized ladders. In each test, the ladder has an attachment fitting at a very specific point. This is the applied load point. From this is hung a specified weight, and then a pulley is fixed at the wall level with the ALP to allow an increasing sideways force to be exerted onto the ladder. For the sideways slip test, this is 60 kilograms dead weight on the ALP, and to pass this test, the ladder must resist 23 kilograms or more, exerting the sideways force. For the flip test, the dead weight is 128 kilograms, and again to pass, the ladder must resist the sideways force generated by 23 kilograms or more. The test for loss of top contact and bottom slip is slightly different in that again 60 kilograms is suspended from the ALP, but this time the horizontal force is applied away from the wall. The ladder has to resist the force exerted by a 13 kilograms weight. In 2015, Rojak Design Limited commissioned the British Standards Institute to put one of their products, the multi-stopper, through the Loughborough test regime. Here, the stabilised ladder set at 65 degrees is being tested to see if it prevents sideways slip. It has 60 kilograms suspended from the ALP, and to pass it has to resist the force generated by the weight of 23 kilograms pulling sideways. Here, the stabilised ladder set at 65 degrees is being tested to see if it prevents flip. It has 128 kilograms suspended from the ALP, and to pass it has to resist the force generated by the weight of 23 kilograms pulling sideways. It actually resisted up to 57 kilograms. Here the stabilised ladder is being tested to see if it prevents bottom slip and loss of top contact. It is 60 kg suspended from the ALP, and to pass it has to resist the force generated by the weight of 13 kg pulling outwards. It actually resisted up to 55.7 kg. We attempted to put the naked ladder through the sideways slip test, but as soon as we loaded the dead weight of 60 kg from the ALP, the ladder flipped, so we couldn't do the test. In test 5, we attempted to put the naked ladder through the flip test, and this required 128 kg to be suspended from the ALP, but the ladder just collapsed, so the test was abandoned. However, this same ladder, when enhanced with the multi-stopper, passed all tests, some by a margin of up to 400%.